I wanted to make a quick video to clarify something that I've been getting a lot of questions on. And this is partly due to the way that the homework problem is explaining things as opposed to how I'm explaining things. So when we're talking about quantum versus non-quantum objects, there isn't a hard and fast line. So there's things that we always think of as quantum mechanical objects, like an electron. So an electron, depending on how you exactly want to count it, you could say is about 10 to the negative 22 meters. But its wavelength is, and this is tough to say with a hard number because it's dependent on velocity as well as mass, but we can give some approximate numbers. Its wavelength is somewhere between 10 to the negative 9th and 10 to the negative 15th, which means that its wavelength is actually larger than the particle itself. And anytime that you're in a situation like that, it's automatically going to be a quantum mechanical particle. Now, there's also a situation like a proton, where, again, depending on the velocity, you could end up in a situation where it's somewhere between about the same wavelength as its size, or maybe about 1,000 times smaller. So is a proton a quantum mechanical particle? Well, most of the time we would tend to treat it like that. Yes, we don't always have to, but occasionally we will. That doesn't mean that it is or it isn't. It's a gradient, not a hard and fast line. So then you can get into a situation like this very large molecule that they were actually able to measure wave-like properties in this molecule. They were using about 85 meters per second for that. You get 10 to the negative 13th meters. So now we're sitting in a situation where the wavelength is, somewhere between 10 to the negative 6 to 10 to the negative 7th times smaller than the molecule itself. So we would generally consider this a non-quantum mechanical object or particle. However, we can actually even measure the wave-like properties of this species. And so to say that it has no quantum mechanical properties wouldn't be correct. However, to say that these quantum mechanical properties actually impact how this molecule is perceived and handled by us might be incorrect. Now when you start getting up to something like a grain of sand, which is in your millimeter realm, and its wavelength is in the 10 to the negative 7th meters, now you're dealing with something where the wavelength is so much smaller than that particle that it is not going to be a quantum mechanical object, even though we could calculate the wavelength. So we could calculate the duality, but it's not going to behave even remotely quantum mechanically. So how do you get these questions right, which is probably what you mostly care about? Well, if you're doing ALEKS, ALEKS has a really narrow definition. ALEKS is defining it as if the wavelength is the same or bigger than the object, then it behaves quantum mechanically. If the wavelength is smaller, then it doesn't. And I think that that's somewhere between narrowly defined to probably incorrect. But it's a computer program and it needs a hard cutoff to be able to have you answer these questions. And so that's what it is. Now, if you're answering questions for me, it's always either going to be pretty obvious, like for instance, a grain of sand is definitely not quantum mechanical, but something like an electron where your wavelength is way larger than your object definitely is. Or maybe I pick something that is a little bit more in a gray area and I ask you whether it behaves quantum mechanically or not, and then I ask you to explain. And in a situation like that, where it's a little bit of a gray area, that first yes or no, does it behave quantum mechanically or not, isn't what I'm actually looking for. What I'm looking at for the grade is the explanation and how well you can explain the answer that you gave. Otherwise, I'll give you something really obvious, one direction or the other, if I'm just asking for a simple yes or no. Because in reality, it's always going to be about what you as a scientist actually care about when you're looking at whatever thing you are looking at.